Hi, my name is Dylan Gajarawala, and along with Kieran Walsh, from whom you'll hear shortly, we did our machine learning project on Kickstarters. In terms of our domain, that's included the Kickstarter community at large, as well as the actual Kickstarter company itself. We wanted to ask what makes a successful Kickstarter project, and we feel that the answers to this question can apply to both parties. Specifically, we were wondering whether it was quantitative measures or qualitative indicators that determine whether or not a project would succeed or fail. In terms of the dataset we used a Kickstarter dataset from Kaggle from the year 2018 that contains information on over 350,000 projects. In terms of data attributes, they include the specific category and main overarching category of the project, the currency and country of the project, and even the deadline of the project and the day it was launched. Now, for numerical indicators, we have the goal of the project in terms of the money, the amount that was pledged, and the number of backers. Now, for projects that were in a currency other than US dollars, a column called USD pledged real and USD goal real were included to normalize all rows in terms of US dollars. When we were exploring the data, we found a bunch of different interesting things. First of all, there are many different project states, 6 in total. These included undefined, live, suspended, and canceled. Also, there were a large number of specific project categories, 159 to be exact. There were a much smaller number of main categories, around 15, so we decided that we would use that instead. Additionally, the currency and country values did not match, so we decided that we would also only use one of those. Finally, there were a few unusable rows, so those would be removed later. In terms of data cleaning, the first thing we did was reducing the number of desired Kickstarter states to 2, success and failure. Although this removed a few rows from our dataset, it was okay. Then we removed the unneeded columns that would not be helpful, such as the name of the project, the goal and pledge amounts in the old currencies, as well as the country column and the specific category. Finally, we created a new column called Days Open, which took a difference between the deadline and the launched column of each row and created a numerical value to represent the number of days that the project was open. This will be very helpful for the machine learning part. Before the machine learning can be started, we first have to pre-process the data. For all the categorical variables, we use a one-hot encoder to make sure the machine learning models could parse the categories correctly. And for the quantitative variables, we use a min-max scaler to normalize the variables so that they could be valued correctly. For example, a goal of a project in US dollars could be in the thousands, whereas the number of days it was open could be 60. This could pose a potential problem in the machine learning process, so thus this normalization had to be done. Now I'm going to turn it over to Kieran, and he'll talk about the machine learning part of the project.
Right. So with our project, we wanted to create a model that could accurately predict the success of a Kickstarter project based on a project's attributes. So this is a typical supervised classification task where we're classifying new projects as either successes or failures based on attributes. In terms of the performance, task, and experience framework, the experience would be using data from past projects and their outcomes to find trends. The task would be predicting the outcome of a new project based on attributes, and the performance metric would be the accuracy of outcome predictions given a test set. So our approach had 4 main steps. As Dylan already explained, the first step was to gather, clean, and prepare the data for our model. And then we selected the best model and features, and then we tested the final model. And then we took the results from our testing and found the value from it. So first, we tried 3 models, the naive Bayes, the logistic regression, and the k-nearest neighbors. We kind of assumed that k-nearest neighbors would be the best model for this problem, just based on the structure of the problem and the data. But we wanted each model to have equal weight, and just try out all the options. So we begin with the Gaussian naive Bayes and logistic regression models. So we trained on a bunch of different permutations of features. So we trained on only the categorical features, we trained on only the quantitative features, and then we trained on virtually all combinations of both. And then we used cross-validation on the training set to gauge the accuracy of each feature permutation for each model. So the outcomes from testing these first two, we found that categorical features did not really seem that important when predicting the success. And then regardless of features, the logistic regression model yielded the least accurate results with only a max of 66% accuracy, and the Gaussian naive Bayes yielded somewhat better results, with a max of 75% accuracy, but it wasn't exactly, what we were looking for. So then we tested the k nearest neighbors model next. And so we only trained it on the quantitative variables because, like I said, we just found that the categorical features were not really that important. So when we use cross-validation, we found that our k nearest neighbors model yielded approximately 92% accuracy on the training set. So because of this, the k nearest neighbors classifier model seemed like the best choice for our final model. And so then we trained the model with three features: the number of backers, the project goal amount in US dollars, and the days that the project was active on Kickstarter, because these seemed like the most important ones. So we trained and we fit the model, and we predicted the outcomes for the projects in the test data set. And so we compared the predictions to the real outcome for each project. Then we generated the accuracy score, the classification report, and the prediction breakdown afterward. So outcomes, the model predicted Kickstarter project outcomes with 91.6% accuracy, which means that it correctly predicted successes 94% of the time and correctly predicted failures 89%. And it correctly classified 75,096 976, projects out of 82,919 total projects in the set. So we thought that this was pretty good. So a few key takeaways from our work. So when it comes to trends, we found that the number of backers, the fundraising goal amount, and the number of days active are the most important, and that category and currency are not really that important for the success of each project. So some significance for Kickstarter users: whenever trying to grow their project, they should attract as many backers as possible. They should set a realistic goal amount and a realistic project duration, and all types of projects can really succeed regardless of category or topic. And then significance for the Kickstarter company, right? So more project successes means more profit for Kickstarter. So Kickstarter should sponsor projects that have realistic goals and timelines in order to increase the amount of backers and then increase the likelihood of success for those projects. Thank you for taking the time to listen to our presentation.